Okay, so moving on to the next page here, we have the title Replacements for Translations. So this is a little bit of a review and some rules we have here on page 78. Given the function y equals f of x, replacing y with y minus k basically describes a vertical translation up and down. So we can either look at it like this, where we have the negative k on the same side as the y, or we bring the k over to the other side. In this case, notice the negative changes to a positive. If we replace x with x minus h, then we're getting what's called a horizontal translation. And we know that if we have x minus a number such as x minus 2, this will actually shift it to the right by 2. So notice we've got some values here for h and k. If h is greater than 0, and that means that we'll read x minus another number, positive number, such as x minus 2. So here, notice h is equal to 2, not negative 2. H is actually 2. X, negative, negative, so 2 is h. When h is greater than 0, the graph moves to the right. When h is less than 0, when it's negative, that means this will change to a plus sign in here and it moves to the left. K, same thing happens on this side. Actually, sorry, not quite the same. If it's plus a number, such as plus 5, then the graph moves up. If it's minus a number, k is less than 0, the graph moves down. So let's go to class example number 1. Okay, what happens to the graph of the function y equals f of x if the following changes are made to the equation? We're going to replace x with x plus 2. So in here would be x plus 2. So f of x plus 2. So this is right beside the x, and so it affects the left and right values, and because it's x plus 2, it will shift it actually to the left, 2 units to the left. Notice here we're replacing y with y minus 8. So if it was something like y equals x squared, it becomes y minus 8 equals x squared. We can bring the 8 to the other side and see that it would actually move vertical translation 8 units up. So if we're affecting the y, it's a vertical. If we're affecting the x, it's a horizontal translation. Class example 2, describe how describe how the graphs of the following functions relate to y of f of x, y equals f of x. So here simply it's moving 3 units to the right. We've affected the y, the whole thing has moved up, or has increased in value by 4. So it's moved up vertically by 4 units. Two things have happened here. We've got this and we've got this. So this means we can move this to the other side. It will be plus 1. So it's a translation 1 unit up, and this would be 10 to the negative side, or 10 units to the left. Class example 3. Point 2, negative 3 lies on this graph of y equals f of x. State the coordinates of the image of this point under the following translations. What's going to happen to this point if we do the following things? So instead of y equals f of x, it's changed to y plus 8 equals f of x. In other words, y has gone to y plus 8. So bringing the 8 over, it's more obvious. This would be a negative 8 over here. So everything goes down by 8 units. So what's affected? Not the x value. The x value stays the same at 2. But negative 3 will change and go down by 8 to negative 11. Okay, what's happening here? Two things. The x has been affected. That looks like a move to the right by 7. So that means x's will increase their value by 7 if they're moving to the right. So 2 plus 7 is 9. So this is 2, I'll just put 2 plus 7, comma, and then we're moving up by 5. So we take the negative 3, negative 3, and move up by 5. So we're adding 5, and it becomes a value of 2. This is another way of looking at it. X has been replaced with x minus 7. That's what's happened here. And y has been replaced with y minus 5. In other words, if this positive 5 was on the other side, y would have been replaced with y minus 5. So yes, it's a translation 7 units to the right and 5 units up. Class example number 4. Write the equation of the image y equals f of x after each transformation. A horizontal translation of 5 units to the left. Now 5 units to the left, that's going in a negative direction. We're actually replacing x with x plus 5. So instead of y equals f of x, it'll be y equals f of x plus 5. If we're translation of 5 units up, y gets replaced with y minus 3. So instead of y equals f of x, we get y minus 3 equals f of x, or we can move this to the other side and it's more obvious what's happening in that we're going up by 3. Again, what happens if you have a translation m units to the right, p units down? Well, m units to the right is in the negative direction, and it's a translation, horizontal translation, if we're going to the right, so that's going to affect x. It's going to the right, so x will change to x minus m. Minus m is going to the right by m units. Also, we're going p units down. So y will change to y plus p, going down. So notice when this number here is with the variable, or this number here is with the variable, the signs actually react in the opposite way we'd expect. This goes actually in a positive direction in the horizontal. This actually goes in a negative direction in the vertical. Well, let's look what will happen. We have y equals f of x. We start with y equals f of x, but y has changed to y plus p, x has changed to x minus m. And now just moving the p to the other side, we get our final equation, y equals f of x minus m in brackets minus p. Looking at the final page, class example 5, given the graph y equals f of x, sketch the graph of the indicated function. Okay, so the answers are actually combined on these graphs already. The original graph is this one here, starting here. This would be y equals f of x. And what are we doing? We're really moving it to the right by 2. So everything moves right by 2, right by 2. So that moves there, that moves to there. This point moves to here, this point moves to here, and this point moves to here. So what you want to do in an example like this is take specific points that are obvious. So usually at vertices like this, or at the ends of the line, here and here, here and here, and move them in the direction that the translation takes place. Now this would be the original y equals f of x, and what's happened is two things. Notice this means actually down by 2 and left by 3. So this goes down by 2, and left by 3. this goes down by 2 and left by 3. Down by 2, left by 3. Down by 2, left by 3, and you get, and this goes down by 2, left by 3, and you end up with all these new points on your graph. And so you can graph the translation. Okay, replacement notation and mapping notation. Two things to think about here. Do not confuse mapping notation with the notation we've used for replacements. So, consider the example where the graph of y equals f of x is transformed to this. In this example, the replacements for x and y may be written as x has gone to x plus 3. Okay, so that's what's happened here. X has been replaced by x minus 3. So this is notation we've used for replacement. And y has gone from y here to y minus 2. So again, this is replacement notation, what we're talking about here. Under this transformation, all points on the graph of y equals f of x will move 3 units to the left, to the right, and 2 units up. The point with coordinates 4, 6, for example, will be translated to 7, 8. Okay, 3 units to the right, so we're adding 3 to that, and 2 up, so that will become 8, 7, 8. Sorry, 3 and 2. In general, the point with coordinates x, y will be translated to the point of x plus 3, y plus 2, when this is occurring. The mapping notation for this translation may be written as the following. Okay, that's the mapping translation. X and y, the original point, goes to the new point, coordinates of the new point, x plus 3, y plus 2. So, this is replacement notation, and this is mapping notation. Notice that mapping notation here is not the same as replacement notation. Similar, but slightly different. Mapping notation, xy goes to x plus 3, y plus 2 is equivalent, though it's equivalent to the replacement notation. A little bit of semantics there, but important to know. Okay, last example says here, state the coordinates of the image of this point under the translation described by xy goes to x minus 7, y plus 4. So we're taking away 7 from the x value, so that should go to negative 10. Okay. So it's negative 3 minus the 7 is negative 10. So we have y plus 4, so that's 5 plus 4. 5 plus 4 is 9. So here's our new coordinate. Our original point here has gone to this new point here. Write the equation of the image of y equals f of x after this translation. It wants the equation. Well, notice x goes to x minus 6. Okay, and y goes to y plus 1. So what does that mean? X is getting less here because it's becoming more negative. So the x value is going to the left. So x coordinate is 6 less. So it's a translation 6 units to the left. What's happening here is the y is getting bigger. So it's 1 unit up. This point, the x has got less and the y has got more. Now, if we are putting this into the equation, the original equation being y equals f of x, what's the new equation with these two translations? Well, 1 unit up, we'll skip this equation here, but 1 unit up means we'll add 1 at the end, and 6 units left, that's the negative direction, we're going to have to use x plus 6 in this notation here. So x plus 6 means left by 6, plus 1 means up by 1. Okay, so I don't have my textbook with me at home tonight, but please look at questions 1 to 10 and do all of them. If there happens to be one question that has, say, 6 A, B, C, D, E, F, G, then maybe do the odds for that if you're running out of time. And we'll see you in class tomorrow.